Hey guys, welcome back to another math lesson. Today we are talking about rate of change and how that relates to slope. So you may often hear the phrase rate of change instead of slope. So rate of change is just another way to say slope. And we know that slope is a comparison of the change in y over the change in x. You may also see it as rise over run. Yep, that's it. So we're going to leave it at that. Slope is how much one thing is too. So if you kind of let go of the idea that it has to go through 0 on the graph, slope is that piece that you multiply by. It's going to tell you how fast, how steep the line is going to climb. So we're doing more of the same. The idea that rate of change is just like your constant of proportionality, except that there's going to have to be an adding piece to kind of twist your line a little bit to bump it up or down on the y-axis. So let's look at how to find slope from coordinates. That's where we're going to focus today. Slope from coordinates. To find slope, you have to have two coordinates. So let's say I have -3, 1 and -2, -2. Now, slope can be positive or negative. So the hard part here is going to be figuring out if this is going to be a positive slope or a negative slope, but we'll tackle that. So the first thing we have to do is we're going to label x, y, and then x2. We're going to label. Identify your x1 and y1 and your x2, y2. And this doesn't really mean anything other than it's going to solidify the order of which we subtract. So I'm going to give this x1 and this y1, make this x2 and this y2. The ones and twos only just mean this is the first x, this is the second x. Next, we're going to set up our formula. We're going to do 2, we're going to do y2 minus y1. We're going to put it over x2 minus x1. So which one was y2? y2 is -2. Which one is y1? 1. Which one was x2? -2. And what about x1? -3. So that might be the hardest part. Identifying just your stick. This could have been x1. That's fine. Just wherever x1, it has to be partnered with your y1. And then making sure you match them up this way. And now we're going to subtract. So -2 minus 1 is -3. And -2 minus -3 is +1. And so the last thing we're going to do, and remember we're finding slope, that's what this whole kind of thing is right here. We're going to reduce the fraction. So -3 over 1 reduces to just plain -3. So my slope for these 2 points is -3. I could extend it and find the y-intercept by plugging in an x and a y and the slope. In fact, let's go ahead and practice because I know that's something we've struggled with in the past. So if I pick a coordinate, I'm going to pick the first one. So I'm going to use -3, 1, and I know that slope is -3, which means the line is going to be going down from left to right. So if I use my formula, y equals mx plus b, what am I going to use for my y in this situation? 1. So I'm going to plug in my 1 for y from here. How much is m? It's -3 from right here. So m is -3 from right here. What about x? X is also going to be -3 because I got it from right there. So x is -3. And then plus, do I know b? No, I don't know b, so I'm going to leave b a b. So -3 times -3, +9 plus b equals 1. And what is the opposite of adding 9? I'm going to minus 9 from both sides. 9 minus 9, 0. So I can cross those out, which leaves just the b. And then 1 minus 9. That's -8. So b in this situation would be -8. So if I wanted to write my full-on formula when given 2 points, first I find the slope by doing this, and then I can plug in slope and a coordinate to get the b, so that my final equation is y equals, m is how much? -3x plus -8. Now, I don't really like the plus and negative like that, so I could put parentheses around it to separate it. Or I could say y equals negative 3x minus 8. Because -8 is the same as adding a negative. All right, so that is linear equations from coordinates, how to find slope, how to find y-intercept one more time. Again, it just takes practice, practice, practice. Once you get the hang of it, you'll think it's easy. See you guys next time.